Hey, what's up, Chem peeps? Now don't get salty, we've got another video here to watch. In this vid, we're gonna explain how salts can affect the pH of a system. 3 things we're gonna do. 1, we're gonna predict whether or not a salt will be acidic, basic, or neutral when placed in water. 2, we're gonna explain the process of hydrolysis. And then finally, 3, we're going to explain how to determine whether or not a given ion will hydrolyze a water molecule. Alright, so at this point, we should all recognize that a salt can be written as the product of the neutralization reaction of an acid and a base. As you take a look at your screen and in your notes, you're provided with the generalized formula for a neutralization reaction. Recognize that the hydrogen from the acid and hydroxide from the base are going to come together and form water. The cation of the base and the anion of the acid will then come together and form your salt. Generalized formula. Now, the acid-base properties of a salt, whether a salt will be acidic, basic, or neutral, can be predicted by writing the formulas and analyzing the strength of the parent acid and base that salt formed from. So first, let's just look at some of the different combinations of strong acid, strong base, weak acid, strong base, weak base, strong acid, to see what I'm talking about. The neutralization of a strong acid and a strong base is going to give a neutral salt. The example on your screen shows the neutralization between hydrochloric acid, a strong acid, and sodium hydroxide, a strong base. The salt that forms, sodium chloride, is a neutral salt. It's not going to affect the pH of the solution. However, the neutralization of a strong acid and a weak base gives an acidic salt. In the example on your screen, you've got hydrochloric acid, a strong acid, being neutralized by a weak base, iron 2 hydroxide. The salt that forms iron 2 chloride is considered an acidic salt. It will affect the pH of the solution. It'll be a slightly acidic solution. Neutralization of a weak acid with a strong base gives a basic salt. The example on your screen, you've got hydrosulfuric acid, a weak acid neutralized by potassium hydroxide, a strong base. The salt that forms, potassium sulfide, is considered a basic salt. It will affect the pH, creating a slightly basic solution. So, in summary, how can you tell whether or not the salt that forms in a neutralization reaction will be an acidic salt, a basic salt, or a neutral salt? Always go back to the parent acid and base. Were they strong or were they weak? The strong one always wins and determines whether or not that salt will be acidic, basic, or neutral. Let's take a look again at that first example. Hydrochloric acid and sodium hydroxide. Both of these are strong. Strong acid, strong base. Neither one wins, and therefore we create a neutral salt. In the second example, we have a strong acid, HCl, but a weak base, iron hydroxide. So the salt that forms is an acidic salt because that strong acid won out. In the third example, we've got a weak acid and a strong base. The salt that forms, we can predict, will be a basic salt because, again, strong always wins. Yes! Alright, now how is the salt affecting the pH? What is going on? Whether or not the salt will affect the pH of a solution depends on whether or not the ions that make up that salt can hydrolyze or split water to any significant extent. So again, you've got a general formula for a neutralization reaction. I've split out the ions of that salt, the M cation and the A anion. If the cation can split or hydrolyze water, and I have broken out water here into H and OH. If this cation can split water, and it will do that by hooking up with the hydroxide part of the water, we say then that salt is an acidic salt, because what's happening is that cation is splitting water and creating additional hydrogen ion. If the salt is a basic salt, then the anion will be able to split water. But if the anion splits water, the anion is going to hook up the hydrogen ion part of that HOH water molecule and leave additional hydroxide ion. All right, let's go back once again and take a look at those 3 examples. First, let's do sodium chloride, a neutral salt. As you think about the cation, we want to think about whether or not this thing will hydrolyze water. Will sodium split the water molecule? Think about it. It will form potentially sodium hydroxide. And that's not going to happen because sodium hydroxide is a strong base. It stays ionized. Chloride ion. Is it going to split the water molecule? Will it hook up with the hydrogen ion to form hydrochloric acid? Also not going to happen because HCl is a strong acid and it's going to stay ionized. So neither one of the ions that make up a neutral salt will hydrolyze water. No additional hydrogen ion or hydroxide ion will form, and therefore we say it's a neutral salt. Strong acid, strong base produce neutral salt. No hydrolysis of water occurs, no additional hydrogen ion or hydroxide ion in solution. All right, let's go back and take a look at that acidic salt, iron 2 chloride. Will the cation split water? In this case, it will. The iron will split it and form iron 2 hydroxide. Now this is going to happen because iron 2 hydroxide is a weak base. It's weak, it's going to stay together, it's not going to want to ionize. So the iron 2 ion will split water, forming additional hydrogen ion, making the solution acidic. The chloride ion is not going to split water. Again, as you think about what's going to happen here, it could potentially form HCl, which is a strong acid. And it's strong acids, strong bases, they stay ionized, so that HCl isn't going to form. So with a strong acid and a weak base, you're always going to get an acidic salt. The cation hydrolyzes or splits water, an additional hydrogen ion is formed. All right, lastly, let's take a look at that basic salt, potassium sulfide. Let's take a look at the cation potassium ion. It is not going to be able to split water. Potassium hydroxide is a strong base. It's going to stay ionized. The sulfide ion, however, will split water. It is going to form additional hydroxide ion in solution because H2S, hydrosulfuric acid, is a weak acid. So it's not going to want to ionize. So it's going to split water and stay H2S. So if you have a weak acid and a strong base, we're going to make a basic salt. The anion of that salt will split water, creating additional hydroxide ion. All right, that does it for this vid. Have a fantastic day.